Hello, everybody. My name is Ann Merchant, and I work for the National Academy of Sciences, and I am joined by
Rick Lovard. I also work for the National Academy of Sciences for the Science and Entertainment Exchange.
Exactly. So if you've been to our events before, you kind of know how the top of the show goes. But my job is to start by explaining to you what the National Academy of Sciences is and does. And essentially, we were created more than 150 years ago by executive order by Abraham Lincoln, who understood at that time how important it was to create good policy that was based in evidence, based in expertise, and that the National Academy of Sciences could help do that. Our very first study was for the US Navy, where we were asked, as we transitioned from wooden ships to iron ships, how our compasses would work. And so I believe that Lord Kelvin, they only needed one guy in Britain, but we needed a National Academy of Sciences. So that was our very first study. And we have, of course, been of service to the nation in both science, engineering, and medicine. So collectively, we are the National Academies. But we're here as National Academy of Sciences employees and to welcome you to today's event. It's the first time we've done a film. We haven't screened a film before, but I think when Rick talks to you a little bit about the Science and Entertainment Exchange, you'll understand why it's so important that science is communicated through the medium of film and through good documentary filmmaking. And of course, we're going to hear from our filmmaker who will be able to give us his perspective on that as well. But I also wanted to say something about the topic of this. You know, the National Academies is also known for its convening power, that we have this special place, and I don't mean just a physical place like a building, and these days we don't have that, but that we are considered to be neutral ground. We can convene people from all different spectrums of a conversation and have a really important discussion. And so we did that in 2015, I believe, was the first summit on genome editing. And we did that in Washington, D.C. at the National Academy of Sciences. And actually, many of the people whom you saw in the film are members of the National Academy of Sciences and sit on our committees regularly, because this is not the first time we've turned to this topic and thought deeply about it. But that summit was a really important point where the community came together and made some recommendations about how technology like gene editing should proceed. And then it was several years later that they did the second summit, this time in Hong Kong. And I have a number of colleagues that were landing together on a plane and then landed to the news as their phones, when they turned it on, that a Chinese scientist had announced that he had already done gene editing on human embryos and that twins had been born from that. And so you can imagine and that scientist was scheduled to speak at the summit. So this is something that is very important to us as an institution and certainly important in science. But I think that we also know that communicating these things through something like the medium of film is really effective to get to a broader community. And that's why the Science and Entertainment Exchange exists. That's my segue, Rick. That's you.
Oh, man, you just threw it to me. All right, so if you are a writer, producer, studio executive, or actor, you have a question about science as you're making a feature film, a TV show, a video game, any piece of big media, it's our job here at the Exchange to be the bridge between the storytellers in our culture and the field experts in a variety of fields. So basically, you can call our 800 number, which is actually 844-NEED-SCI, if you have a question about science, or you can email me or Sachi if you are a STEM professional in the audience and you're just like, wait, what's going on? You do what now? Please, if you're interested in engaging in this kind of interaction, we would absolutely love to get you involved. We've done over 300 events like this one and live in person, in real life events before all of this, the current new way. And we've done over 3,200 consults, including Avengers Infinity War. I'd like to thank a couple of people, our AV team who made this possible today, in particular Ameche, the DC staff who helped support the program back in DC, Courtney Sloan, Jeff Fishman, and Sachi Gerben here in LA. I'd also be remiss if I did not thank our sponsors, Howard Hughes Medical Institute, who made this event possible, Alfred P. Sloan Foundation, Walt Disney Company, Film Nation, Google, Lyda Hill Foundation, Corteva, and individual donors, many of whom donated today who are in attendance. If you donated at a supporter level, you will be getting one of these from us. And it's a thank you, but also this is our last event for this season. Next season, we've got all sorts of plans for how to give you some VIP access to ask questions over Zoom in person to our speakers. So we hope that's another way to say thank you. Anne, did you have anything else before I go into the event structure?
Yeah, I guess I did want to say that it's interesting that all of our panelists, speakers, including our moderator, have been part of the Exchange family through our retreats. Part of what the Exchange usually does, not now, is that we convene small groups of people over the course of a long weekend, and it's usually filmmakers and scientists in equal number to have conversations that we feel sort of inspire the way in which science could be incorporated into filmmaking. And we also annually do a documentary filmmakers retreat because we do understand the real value of documentary filmmaking as part of the overall entertainment portfolio. So all of the folks we have here today, not only in addition to their other bona fides, we think it's a bona fide that they've been part of our retreats. So we're very glad to have them all here today. And I guess the other thing is, of course, that we always do is we talk a little bit about some of the stuff we've seen or done, just so that we keep going with the very personal vibe that we hope that these events have. So I wanted to say that I learned about the Venmo challenge. And the Venmo challenge is that people are using Venmo to collect very small amounts of money, 50 cents or $1. And once they get enough people to contribute to a small fund, that person will go out and make a special gift to a waitress as a $600 tip, or to the staff at Dunkin' Donuts that have been at that drive-through window every day to be able to give people cups of coffee, or somebody who can't make their rent. So I've been giving those little dollars to be able to be part of the Venmo challenge. I thought that was fun. I also discovered, and Sachi's going to give you the link. It doesn't sound like it's a big deal, but brown butter tomatoes. Tomatoes, the best part about summer from my point of view are fresh tomatoes. And if you just put a little brown butter on them, as a friend of mine said after I told him this, major. So it doesn't sound like much. It's a way to make a tomato unhealthy, but also incredibly delicious. Food 52, get that. And I also discovered Caesar the No Drama Llama, who's a llama activist. And apparently he is the grand champion llama. I don't know what he's a grand champion of, but he has been walking the streets and making people feel good. So there you go. Oh, and the last thing I wanted to say is for anybody who has not read the science articles coming out from Ed Yong at the Atlantic, you should read his work. It's incredible. He's a gifted writer. He does really, really good research. And I have found that they've been some of the most informative things around the COVID pandemic that I've been able to find. So read Ed Yong. And you probably have some stuff, and I don't know what that guitar is back there, but.
Well, this guitar is not a Fender Stratocaster. It was built from parts ordered on the internet. So this is a Franken guitar behind me. Yeah, I wanted to just say that, each week I've been trying to pick out a word that I find online that I'm like, I need to reintroduce that word to my vocabulary, or maybe introduce it entirely to my vocabulary. This week, my word was sclerotic, which means becoming rigid and unresponsive and losing the ability to adapt, which I thought was particularly apt given the topic that we're doing this week. So what you're about to experience is a conversation among many people who are involved in the film. And at any point during the conversation, and some of you already have, please feel free to ask a question. Right down there, it says Q&A. And I am going to be pulling as many questions as I can. There are a lot of you in the audience. We're going to have a very limited time, so I apologize if we don't get to your question. We'll get to as many as we can. So I'll be pulling questions and handing them over to our moderator and back to Anne.
Yes, our moderator, Monica, and I'm so happy that you're here because, as I say, all of our participants today are from our retreats. But the thing that I really just want everyone to know about Monica is that, yes, she is a PhD scientist, and so she's got the piece of paper. That's a good thing. But I think that what I have always enjoyed about, I have been in Monica's audience before when she's given talks about the work she does with the Wonder Collaborative, and she's got other things we could tag her to, but today we're tagging her to the Wonder Collaborative, and she'll explain a little bit about what that is. But Monica is one of those incredibly gifted communicators that can just tell you a story about her life, and just make you want to listen. And I've heard her tell different stories, and I always, when I know that she's on the agenda, I make sure I'm in the room, because and it's so important for scientists to be able to talk about their work and to be able to make it relatable. And Monica is one of those very gifted people who can do that. So we are really, really happy that you could moderate this conversation. I know it's something that you're highly capable of doing because you know this film really well and you know the people. But not only that, we just are super happy to see your face on our screen. So thank you, Monica.
Thank you very much, Anne. That's a very kind introduction.
Heartfelt.
Thank you. Thank you so much. And thank you, Rick. Thank you, everyone at the Science Entertainment Exchange, for having me and for hosting this conversation about Human Nature, which is a documentary that explores the science and the social implications of gene editing, particularly of a technology commonly known as CRISPR. As Anne said, my name is Monica Felio Moher. I am a scientist and a producer at the Wonder Collaborative, which produced this film and is part of iBiology, which is a nonprofit organization that uses videos to convey the excitement of modern biology and the process of scientific discoveries. Just briefly about me, my work focuses on using communication and storytelling to make science more equitable and inclusive. So I have the honor of moderating this conversation today between two of the experts who are featured in the film and one of its executive producers. So I'm going to go ahead and briefly introduce them and welcome them to our virtual stage. First off, we have Alta Charo, who is a bioethicist at the University of Wisconsin. She's also a member of the National Academy of Medicine. Welcome, Alta. We have Tashaka Cunningham, who is a co-founder and chief scientific officer of True Genomics, which is a precision genomics biotech company. And he is also the executive director of the Faith-Based Genetic Research Institute, which is a nonprofit organization that engages minority communities with genomics research. Welcome to Shaka. And last but not least is my colleague at iBiology and the Wonder Collaborative, Elliot Kirshner. He is the executive producer of Human Nature, and he's also executive producer of the Wonder Collaborative. He's a New York Times bestselling author, and he's an Emmy Award-winning news and documentary producer. Elliot, welcome. Excellent. So we're going to jump right in. So the conversation that we're going to have today is going to be based on the film. If you haven't watched it, don't worry. The link that you received when you RSVP'd is going to be available till tomorrow. So if you want to watch the film, you have a chance to do it by tomorrow. If you don't worry, because the film is going to be widely available soon. It's going to be on Nova on September 9th. It's going to be broadcasted at 8 p.m. Eastern Time on Nova, September 9th. And then it's going to be available on Netflix. It's starting October 1st. So there's going to be lots of chances to watch the film and to share it with the world. So because I know some people maybe haven't had the chance to watch the film, we're going to show short clips from the film, and then we're going to ask questions, get the conversation going, and then we'll go to your questions towards the end. So I want to get everyone on the same page. We're going to start with the clip that's going to provide you a general overview of gene editing. So Amici, let's go and play that first clip of the Homology Directorate Prepare.
If you can cut a gene inside a cell, so if you can create a break at a place of interest, then you can change that gene. You fool the cell. Give it a separate piece of DNA that you have made. A piece of DNA which is identical to the chromosome that you're cutting, except for the change that you wish to make. And Mother Nature will not know she's being fooled. She will repair the break using this piece of DNA you provided as a template. And so whatever change you brought in will then go into the chromosome.
You can think of it like a cursor in Microsoft Word. In Word, if you have a document where you edit first, you have to place the cursor there. In DNA, wherever you make a cut is the equivalent of a cursor in this word processor of the genome. That's where you can type in a new word.
So if you wanted to use that capability to engineer the genome, the challenge was to introduce breaks in the DNA at places where you wanted to alter the code.
How are we going to do that? We need something that cuts only one gene out of the 25,000 that we have.
Now, of course, CRISPR is not the first or the only gene editing technology that scientists have available, but what's really revolutionary about CRISPR is that it allows to make these edits with really amazing precision, and the technology is relatively cheap and easy to use. Such revolutionary technology like CRISPR really opens the door to many potentially transformative applications, like the treatment of genetic diseases like sickle cell disease. And in this film, we meet David Sanchez, who is a young boy with sickle cell. And I'd like to play a short clip about him before I jump into a question for Tashaka.
David can go from crazy teenager, joking, jumping around, to a fetal position on his knees.
It's like pulsing. This hurts. You're having a sickle cell crisis. I can have like a little pain crisis where it really doesn't count, and then I can have something really bad. But I'm not just gonna not play basketball. You can't just not play basketball.
This is David's old red blood cells. We're gonna save for research.
It's a genetic disorder. So in order to cure a genetic disorder, you literally have to go in and fix the gene.
One of the things that I love about this film was hearing David's own voice. There's no mediator. You really get a sense of what it's like for him to have and live with sickle cell. And using CRISPR to treat diseases like sickle cell, it raises really important questions about ethics, but it also raises really important questions about equity. And that this is one of the topics that I'm incredibly passionate about. So I'm gonna take the privilege of starting with this. So this raises a lot of questions about who will be able to access and benefit from technologies like CRISPR, and how do people from marginalized background, how do they get to participate in the decision-making process about how these technologies are used and applied? And so, Tashaka, I'd love for you to tell us about some of the conversations that you've been having as you engage with minoritized communities about on the topic of CRISPR.
Thanks so much, Monica, for that question. I think it's a great question. And every time I see that clip of David, it's such a powerful clip. It actually reminds me of one of my dear friends and colleagues who had sickle cell, who I lost. Actually, he died from it at 34. He's actually one of the people the film is dedicated to. His name was Shakir Cannon. And when I think about the conversations I have had with Shakir and others, particularly African-American minorities in the community, is really a hunger for knowledge about these new technologies and how they can help them. I think the medical establishment has a long way to go in this regard to really properly educate and outreach to these populations and really make sure that everyone has equal access to these technologies like gene editing, even genetic and genomic testing, and really things that can improve people's health. I'm very passionate about that. I work with a number of organizations over the years to make sure that we're communicating this to communities properly and making sure that some of the folks who are doing the messaging are also from the community. That's actually a common theme in the work that I do, is making sure that the scientists and researchers that are the communicators of what these technologies are from those communities that are African American, Latino, and others. And I'm lucky that we do have a critical mass of enough scientists of color out there that can be these honest broker messengers to carry this message to the community about what these technologies are and to let them know how they can benefit them.
Awesome. Alta, I was wondering if you could comment on, from your perspective as a bioethicist, how do we go on to engage minority communities who unfortunately have been oppressed, have been marginalized, have been abused by science before? Oh, you're muted, Alta.
I'm sorry. When I worked with the National Academy of Medicine's Genome Committee, we heard from a variety of people, and one of them was someone who was the head of one of the sickle cell anemia chapters from Tennessee. And you'll see him in the film at one point. You may recall, for those of you who saw the film, a moment when a man said, "Whatever will keep my child from suffering, I'm for." That's the way you reach people from my perspective. You find people who know about this personally and have lived that experience, and you offer them an opportunity to do something that might help. And somebody like Trevor, who also unfortunately has now passed away from sickle cell, is exactly that kind of honest broker you were talking about, Tashaka. He's lived it, and he's also spent his life devoted to trying to do something for other people who've lived that experience. And he can talk to people in a way nobody else can.
So personal stories. And those personal connections, Tashaka, you mentioned, there's enough scientists of color out there to do this engagement. Believe it or not, there are enough of us out there to do this engagement. And for some of us, it is a big motivation to do the type of work that we do. Before I move on, Elliot, I wanted you to briefly comment as a filmmaker. You and I have been participating in a lot of conversations around the film, and we've noticed that this issue of equity and access comes up a lot. So I wanted you to talk about it from your perspective as a filmmaker.
When you make a film, you have a lot of power as a storyteller. And the biggest power is essentially, whose story you're going to tell, whose voices are you going to hear. And one of the tropes of science filmmaking, and it works for a lot of reasons, is they're often narrated or they have a host. We made a decision very early on that we weren't going to do that. It made it more difficult in some ways to explain a very complicated topic. But I think when you have a filter then there's essentially a sense that what scientists say or what your speakers in your film are saying needs to be translated for the public, that there can't be a direct dialogue. And I think that it serves a purpose, and there can be uses for that, but it can be very damaging because it creates a sense that we're not all speaking the same language, that we don't have the ability to speak the same language. I think that is not true. I think that scientists are also part of the general public. When scientists step out from their own specific disciplines, they're just another sort of educated member of the public. And I think that also really expands to who gets to speak. Often patients are props in films around science. Doctors speak for them. Doctors explain what they're doing, their story, or what they're talking about, what their own personal pain is, or that journey, but their own agency as somebody who deserves to have their voice heard. And especially, and that's incredible. That's even more of a problem for people of color. It's more of a problem often for women. It's more of a problem for young people. And I think we're living in a time where we're seeing what happens when voices are discounted. So we made a decision very early on in this film to let everybody speak for themselves. And some of the most powerful moments really are the story, really David Sanchez's story, and it resonates with a lot of people. And he has every right to be heard. And what he says is just as profound. And we've seen this when he's appeared on panel discussions. He has a lot to say, and he deserves to be heard. And so I think that as filmmakers, we need to, it's our burden in a way to do the hard work to make sure that people's voices can be shared directly with the public. And I think that's especially important for disadvantaged groups or people who literally have had their voices been told by society it doesn't matter. And I would, in some odd sense, I think that also does, extend in some way to scientists who say, well, we don't understand you. Well, that's not good enough in the world we're living in today. And I think that films need to represent that.
I agree 100%. One of the things that I know I've heard a lot because of CRISPR's potential to edit the genome is the statement of are we playing God? I think that statement conveys the enormity of the ethical questions that CRISPR poses and its transformative potential in both, probably the good and the bad. So I'm gonna play, now we're gonna play a clip to explore this a bit further.
Anything that would stop my child from suffering, I'm for.
Draw this ethical line wherever you want, but don't draw it in front of my disease.
He was 6 days old.
I remember one woman told the story about a child she had and died of an inheritable disease.
He had seizures every day. We donated his body for research. If you had the skills and the knowledge to fix these diseases, then freaking do it.
The statement of task demanded that we try to follow the evidence and follow the logic, not that we follow the politics. We said, we conclude it is not intrinsically evil. It is what we called ethically defensible. But we understood that this was now a break from the past in the thinking on this topic. Yes.
In Genesis chapter 1, we discovered the concept of the imago Dei, being in the image and likeness of God. What does that mean for this science, where we have the capacity to edit in some things perhaps that we think are important? Are we playing God?
Alta, I'll have you start. How do you personally wrap your head around this question of are we playing God? And I mean, how does society?
This is a phrase, playing God, that we hear quite often in the area, particularly of reproductive technologies, going all the way back to the 1970s and amniocentesis and through in vitro fertilization and genetic screening. I think that it reflects the kind of even unspoken, implicit religious culture of the United States. Because for many of the more dominant religions here, there's a vision of a God that is actively involved in the world and directing events. And that one can pray for an event and hopefully it'll be answered, and then that event will play out the way you've requested. And in that vision, there's a role for human beings that's rather modest and a recognition of limits of our own wisdom. But that's not the only kind of religious tradition we have in the United States, let alone around the world. Because if you think about it, with reproduction, if you're talking about classic Mendelian genetics with a recessive or dominant gene, the chance of passing it on to a child based on the parent's own carrier status is 1 in 4 or 1 in 2. And it plays out with statistics. It plays out through randomness and numbers. And in that vision, you have a role of a God that's much more remote, allows things to roll out the way they will. And here, to make a change and to intervene actively is to play human, not to play God. Quite the reverse. So much of it is really just the lens with which you view these events, how one interprets the right balance between modesty and action on the part of the human actor here.
And Monica, I would add, I get this question a lot. And actually that segment, we were in a church in Baltimore where the pastor was, setting up some remarks we were making about CRISPR. We get this a lot in the church, particularly when I go to speak in Black churches. I'm also an ordained Baptist deacon myself. I happen to be a molecular biologist and a deacon, interesting combination. But when I go and talk to parishioners about this technology, that's one of the first questions we get asked. Are we doing something we shouldn't be doing? Is this the domain of the Lord who had ordained things to be a certain way? And I think Alta's point is very well taken because, there's a line that's in people's minds that maybe we shouldn't cross, right? Is there this sort of ethical line where science meets religion and our ability to determine, not be determined, that is scary for a lot of folks. I think we're going to grapple with this with some really incredible technologies like CRISPR that have put that power in our hands now to be able to make these kinds of genetic changes that can be permanent in some cases if we alter the germline. So this is going to require a lot of discussion amongst all manner of people, not just people of faith, but also scientists and lay people. And that's why this film is so important, because it sets the stage to educate everybody about this technology, its origins, and its future impact.
And I think it also gives us a chance to recognize more about the ways in which we are coming to our own conclusions. The more that we understand that this impulse about drawing a line comes from one of the Christian sects, or because you're Jewish or Muslim or Buddhist, you have a very different notion about where the line should be drawn, or even if there should be a line, I think it helps us to articulate our concerns in a way that makes them more understandable to one another. Is it a concern about science? Is it a concern about regulation? Or is it simply that this reflects something that's your own faith and may not be shared by somebody else? That changes how you talk. So self-awareness is very, very helpful.
Yeah, absolutely. And I think, listening to your responses, Alta and Tshaka, I think the thing that comes to mind is, as I didn't know this as much as a scientist, but as a communicator, I think this is one of the most important lessons that I've learned over the past decade and a half, and is that people's context, culture, values, that all influences how we approach problems, how we think about questions, how we value science. And so it's really, really important as we are considering these big ethical questions, not just as scientists, not just as, people from particular religions, but as a society, it's very important that we consider these nuances. And that's why it's so important that we have these conversations. And that actually takes me to my last clip and my last question. So let's play the clip first. And then I'll ask my last questions before we jump into questions from the audience.
I ended up having several dreams that were very intense for me at the time, where I walked into a room and a colleague said, I want to introduce you to someone and I want you to tell them they want to know about CRISPR. And I walked into this room and there was a silhouette of a chair with someone sitting with their back to me. And as they turned around, I realized with a horror that it was Adolf Hitler, And he leaned over and he said, so, tell me all about how Cas9 works. I remember waking up from that dream and I was shaking. I thought, oh my gosh, what have I done?
Of course, this clip is very jarring. But I think it raises some important questions that stem from what we were just talking about. But I'd love to hear your thoughts, Elliot, and how do you hope that films like this one can foster critical conversations and the civic engagement that is necessary for society to wrestle with the good and the bad that comes from these revolutionary scientific discoveries like CRISPR?
Yeah, I think that you have to start by recognizing that science is complicated, society is complicated, these issues are complicated, and we're not doing anybody any service if we just pretend otherwise. We're also not going to do anybody any service if we become polemical and sort of don't challenge assumptions and push people in different directions, and so they come and they just retreat or feel good or just retreat, go to their own little camp. One of the things that really impressed on we needed to make a film. We started off trying to just doing a short film about what is CRISPR. We met with a group of scientists, and what was just so striking is, they're human beings. I mean, I know it might be a surprise to some people, but scientists are not some special subspecies. They are, they breathe and eat and do everything else that everybody else does. And so, and they were concerned about this. They were concerned about it, but they were also hopeful about it, about what this technology was. They were grappling with it, but they were doing it because they were years ahead of everybody else, because they just knew it. They could see it coming. I think we've seen with the internet, what happens when we just plunge into a technology without really thinking about all the implications. And so what really became clear is the scientists themselves wanted to engage with the complicated ethics of this. And they didn't all agree amongst each other, and they had their own views about what this technology should do or what the limits should be. And so our hope was, if we present this to the public, if we don't try to sanitize the complexity out of it, that we would provide something that begin a conversation where people could be challenged for their own beliefs. And many people ask, well, where do you come down? And I think everybody who worked on this film is just as conflicted about it as most of the people that end up watching it. We recognize the good, we can worry about the bad. Alta, has a wonderful phrase in here about being a bio-optimist and a bio-pessimist. The people approach these issues from different sides. But we have to start by making films that are complex. We need to be able to trust the public to deal with this. I think that, oftentimes filmmakers, storytellers, journalists don't trust the public enough. And when you suck out what really the marrow of the story, which is ultimately the complexity, you present something that doesn't resonate as authentic. And I think that it has less power. So I think what films need to do, and the people that support and fund and distribute these films do, is embrace difficult subject matter and not shy away from it, and bring in different voices, give people their airtime if they're responsible, and try to turn that into a story that gets people thinking. And I mean, our hope was not that we would give everybody the answer, but that they would watch this film, and we can't cover every subject matter in it. There's a lot that we haven't even dealt with. But the next time they come across an article or hear someone talking about it, they're prepared. Their antennae is up, and they're like, oh, I want to know more about this. I already have some I have some confidence about this. My voice can also be part of this discussion. And I think that's what really good filmmaking, especially documentary filmmaking, can do.
Wonderful. Yeah, I think one of the things that I think a lot about as a filmmaker, and you and I talk a lot about, Elliot, is how do films, how can they be a spark for action? And that action can be conversations, it could be bringing together seemingly disparate groups of people. And so I really, really appreciate that point. So we have a lot of amazing questions. I'm gonna try to combine some of them because we're not going to have enough time. We have about 20 minutes left. And so I'm just going to start bringing questions from our audience. And so we have a lot of science questions, which is fantastic. And so I'm going to actually combine a couple of questions. So there's, and Shaka, I'm going to direct this to you. There's some questions about off-target consequences of gene editing and how those could play out. And another question, I think it's related to this, is about sickle cell and how it's protective against malaria in some capacity. And so if we, thinking about off-target consequences or maybe unintended consequences of quote unquote fixing a gene, like, how do we evaluate the benefits and potential downsides of those?
Those are great questions. And when I talk about lines, lines that you draw in the sand, as a scientist, one of the lines I have in my mind with this technology is I don't want to alter the germline. I feel like the germline DNA is a public trust. That's just my thing, because I don't feel like with the technology at the stage that it's at, we're as precise as we need to be with it. So that question about off-target effects is real. When these therapies based on CRISPR are making their way through the clinic, the FDA and other regulators are going to be looking at that. How precise are the changes that we make? When we try to change the beta globin gene, are we sure that we're not changing a tumor suppressor gene? Or are we sure we're not introducing some other type of mutation that could be harmful? That's the risk benefit that regulators at the FDA and researchers and clinicians are going to have to figure out. The current state of the technology, we're not that precise yet. It's getting better, but to say I can go exactly to this spot on this part of the genome every single time, we're not there yet. And until we can do that, I think we better proceed with caution in terms of changing germline or permanent changes to the genome. Changes to the individual host genes in the patient is a different story. That's going to be a patient by patient thing, but I think we need to tread carefully there. The other question was about sickle cell. If you change that actual natural adaptation, which many groups feel that sickle cell evolved as people were developing resistance to malaria and other pathogens like that. Heterozygotes seem to have some level of protection, and the homozygotes is really the really deadly situation where you've got you're just not a carrier, but you actually have two copies of the bad beta globin gene. I think that's going to be, again, individual patients. If you're a patient that has that, you're homozygous for this, it's deadly for you. So you're going to want to make that change to improve your situation, even at the risk of you losing your malaria resistance, if you will, right? So I think the sickle cell patient would definitely trade off their life and their pain versus being resistant to malaria, especially if you're living in an environment where malaria is not endemic. So we're going to have to look at these on a case-by-case, almost disease-by-disease basis, and it's going to really have to be these kinds of patient-level decisions that'll be made that determine the best application of this technology to the individual diseases. Great question.
We have a question that's related, and it's actually been on my mind today because I read an article about this today about how communities with genetic disabilities react to CRISPR. I remember from this is a little behind the scenes. I remember from earlier versions of the film, there was a clip, I believe it was with Keith Yamamoto, who was at the University of California, San Francisco, and he was sharing an experience of being in, and Elliot, correct me if I'm remembering this wrong, but he was talking about being in a forum where they were discussing precisely this, using CRISPR to quote unquote fix some genetic conditions and that lead to disabilities. And somebody from the deaf community said, like, I don't need to be fixed. And so today I was precisely reading an article about this, about, people with disabilities. This, we live in a world that is predominantly, the perspectives are predominantly from able-bodied people, and most of us are able-bodied for now. We don't know what might happen later. And so any of you, can you comment on perhaps your experience with these communities and these types of conversations?
You're directing that to Chaka or to?
Any of you.
Also, you want to take that, and then I can add in. Yep.
Sure, certainly. I think that it has become more and more evident that the very notion of disability is complicated, because what is disabling in one context may not be disabling in another. Many of us here on the screen are wearing eyeglasses. we would have been disabled in contexts where eyeglasses were not available and where acute vision was required for survival. But today, not so much of a problem. So one thing is to make sure that we always are looking at how we can alter our environment to make it amenable to people of varying characteristics. And the Americans with Disabilities Act was a really good start, but only a start here in the United States. More subtly, there are some conditions, but I would not say all, for which the condition itself has actually become a defining characteristic that created a community. This is not just about capacities, it's about community. And I think there's two groups in particular, people with deafness and people of extremely short stature, whom some people call dwarves or midgets or little people. There's a vocabulary variations. These are two groups of people that have actually found that they now identify with one another the same way religious groups do, or language groups do, or national groups do. And so for them, there's a particularly strong argument for saying, I don't want to be, as you put it, or as Keith put it, fixed. In the end, though, we are a diverse country with diverse attitudes, and some parents and some individuals will want to use technology to eliminate as many barriers as possible to full participation in the environment and with other people. And will take some chances with the technology. The trade-offs of risk and benefit for them will be in favor of making the changes. And others will say, no, that's not worth it to me. I'd rather adapt, or I'd rather make sure my own community remains vibrant. So I think the crucial thing here is to be tolerant of other people's choices instead of feeling like we should be making a single choice for everybody and using the government to impose it.
I 100% agree with that, Alta, because you not only have to be tolerant, you have to understand that each individual is going to be making some of these tough decisions about themselves and their families. I look at it as different levels of change, right? So the way I look at gene editing, if it's a severe disease trait or something that, like a beta thalassemia or something that could be deadly to an infant, and a parent wants to change that, that's one story. But if it's a sort of, I call it a cosmetic change, like eye color or skin color, maybe we shouldn't be delving into that space. And that's sort of the way I look at it. For example, I'll make it very personal. I love my melanin. The amount of melanin that I express gives me a nice year-round brown tan. I don't even have to go out into the sun for it. But it's also a natural adaptation that I derived from my African ancestors that helps protect me a bit from skin cancer. So I wouldn't lighten my skin by genetics by any stage of the imagination. So I think that it all happens to be what the trait you're trying to change. I think we're going to have these interesting discussions, and the severity that and the potential for it to cause a severe disease. I think these are some of the metrics we're going to look at over time when we decide what should be changed.
Yeah, I think the tough part's going to come with the things that fall into the middle.
Yes.
The things that are neither deadly nor, I'm not sure I would call your melanin cosmetic because it has such social and personal and emotional significance, just as mine does. But I understand what you mean in terms of appearance as opposed to, survivability. But there's a million things that fall in between that are going to be much tougher calls, and where I think we're going to get a lot of variations among people. Asthma is something that kills a few people, but mostly you can live with it, but it is limiting. Should that be something that we tolerate parents deciding to change in their children, or change in a fetus in utero before the child is born? Or, if we ever got to the point where it was safe enough, Chaka, and we may never, but if we got to that point, in an embryo so that the child is never born with it. I mean, that's going to be the kind of question that'll come up with these intermediate kinds of conditions.
Yeah. I want to ask a couple more questions. And one of the questions that I want to bring up now is about CRISPR and how it can potentially be used to combat or mitigate climate change. That wasn't something that was necessarily discussed in the film, but it's, agriculture, climate, there are other applications for CRISPR beyond human health. So can you talk a little bit about that, of CRISPR and climate change?
Chaka?
I'll give it a crack. CRISPR and climate change. Wow, this is going to be very interesting. I think particularly as we start having it applied for different reasons, like agricultural and others, when you're changing organisms, that impact an environment, that is going to create a whole nother set of questions, right, about this. And I think we've been genetically engineering organisms for, hundreds of years, and animals for that matter. And so we're just getting more precise with it. Now with CRISPR allowing us to do that at a much greater level of precision, there's always uncertainty whenever you introduce a change, a genetic change into a natural system. And I use that Jurassic Park analogy, right? Where, it's like, they're like, nature finds a way. They tried to breed the dinosaurs so they would only be female and have this lysine deficiency, but it didn't quite work out. Same thing, once you unleash a mutation into the environment, it's unpredictable on how it's gonna impact the environment. And so as we start having genetically more CRISPR-oriented genetically modified crops, plants, bacterial species, it could potentially impact the environment. I think that's going to be its own field of study as we move forward as to how you modify organisms and the impact on the environment. Unpredictable now, difficult to say how it's exactly going to play out, but it's a possibility that it could impact environmental change over time.
And
go ahead.
Oh, go ahead, Elliot.
No, I think one of the things that we hoped comes through in this, there has to also be a certain humility with our own level of knowledge. And I think that one of the ways that science is taught that's a disservice to science is that our textbooks are filled with everything we've learned. And really, there's very little perspective on all that we don't know. I think it's a real mistake in the way that and often I think the way that science films or storytelling is done is it's a journey towards knowledge where you reach a pinnacle of knowledge and you don't realize, whereas if you go to a scientific meeting or anything like that, it's all about how little we know, where we want to go, what's the next experiment. And so I think that has to be taught, that has to be part of the science storytelling, that there is a lot of uncertainty around this. And I think there's also, we also have a sense that we can screw things up and science will sort of fix it. I think we're seeing that with the pandemic. I think there's a certain strain of that with climate change that we can just engineer our way out of everything. And I think we've seen some of the folly of that as well. So I think what's really important in the way that we talk about these things is that we sort of show the path of discovery and we also show what's left to learn. And I mean, our hope was at the end of the film is that, we have this line which is the end of the beginning. Theodore Arnott talks about, we're a long way from that. There's a lot that needs to be figured out, but we need to have people need, you need to be thinking about things before you get to the point where you actually can do them. And so I think that has to be part of the way that science is conveyed in education and also in sort of popular formats like this.
I just have to add this because Elliot's exactly right, but I'm going to be my bio-optimistic self again over here, okay? Because nothing is without risk. Nothing can be made absolutely safe. So the question then becomes, how do you make it as safe as you can and then ask, are the residual risks worth it? So for example, with engineering crops so that they're resistant to drought, resistant to salinity, other kinds of things we may need in a climate change era. Well, we already have programs that have been developed at the Department of Defense called Safe Genes. The idea is before you let something loose in the environment, you build in a mechanism to slow it, stop it, reverse it. These are mitigation measures. So if you have, as we do have, people dying every year from dengue fever and from Zika virus, you want to change mosquitoes so that they don't transmit those disorders, then you need to build in a mechanism by which you could turn that off if it turns out that you lose control of the mosquitoes. And there are ways to do that. Or ways to reverse the genetic change so that they slowly begin to revert back to the original wild type. So part of this is about recognizing that trampolines in the backyard are dangerous for kids. But trampolines in the backyard that have a big screen around them are still a little bit dangerous, but they're a heck of a lot safer because the kids can't fly off the trampoline and fall on the ground. I mean, that's the trick, is finding that sweet spot.
I love that analogy. And, I think along the lines is, science doesn't happen in a vacuum. And sure, we have to think about mitigation and kind of checkpoints, but we also need to keep in mind that there's politics and there's socioeconomics and there's other things that come into play. as we're considering these issues. So we have time for one more question, so I'm going to direct that to you, Elliot. We have several people asking where they can see the film, where they can find more information. So let's share that quickly, and I'll pass it back to Anna and Rick.
Great. Well, I mean, first of all, thank you all for joining this, and thank you everybody for joining. I mean, you make a film because you want people to see it, and we're very, very excited that people will be able to see it and see it in many different formats. So, as Monica mentioned, you mentioned earlier, at September 9th at 8 p.m. on Nova, and they'll be able to be streaming after that, I think through the Nova website, but 8 p.m. Eastern, then Netflix on October 1st. Also, if you are at an institution of higher learning, there's a good chance you have a subscription to something called ProQuest, and we're available there, which is wonderful. So that allows educators to assign it to classes, and we really hope it becomes part of people's curriculum, not just science classes, but ethics and law and all of that. So you go to ProQuest for that. So, I think it's the more we make, the more people that watch this film, the more people that say they support this kind of filmmaking, the more kinds of films like this that will be made. So please tell people to tune in on Nova, go to watch it on Netflix, share it, write about it, blog about it, tweet about it. We'll try to retweet your tweets if you do, hashtag Human Nature Film is what we're trying to do. Go to the wondercollaborative.org on the website, which you can find out more about the film there. And as I said, ProQuest, if you're at at a college or university, is a good chance. And it really, really, the audience plays a big role in science communication. If people click on articles, if people share them, if people tune in, that tells distributors, that tells funders that, hey, you might be missing something. There really are people out there that want high quality content in the science. So please, please tell people to watch this film. And I think also the link is available for another day. But really, let's get those numbers up on Nova, and let's get those clicks up on Netflix, and we'll be able to go back to the people that supported what we've done and say, look, we need to do more of these. We have a lot of more ideas of films we want to do and stories we want to tell. So please go watch it.
Great. Thank you so much, Elliot. And again, it's wondercollaborative.org. So you'll find more information there about the film and other projects that we have going on. Thank you so much, Alta, Tashaka, and Elliot for your time and your insights. Thank you everyone watching for your magnificent questions. I'm sorry I didn't have time to get through all of them, but I encourage you to use those questions, to have conversations with your friends and your family and your colleagues, encourage them to watch the film and then talk about some of these questions that we didn't have time to cover today. Of course, thank you to the Science Entertainment Exchange for the opportunity, and back to you, Anne and Rick.
This was awesome. And I have to say, I don't know about anybody else, but I was actually watching the film for the National Academy of Sciences cameos, because some of that footage that Elliot got was in our building. So it's kind of fun to see that. And there is a who's who lineup of members of the National Academy of Sciences in there. So that's pretty cool from our point of view. So this has been a great conversation and is so much on mission for the Science and Entertainment Exchange. As Rick said, we're taking a bit of a break. We're going to let everybody have some time off because vacation is important, even if it's a staycation. And so we're coming back after probably this
Labor Day. After Labor Day.
After Labor Day. It'll probably be the week after Labor Day that we're taking a little bit of time off, but we'll be back. We've already been brainstorming a whole lineup for the rest of the year, and we're excited. We hope you are.
Yeah, if Monica didn't get to your question, it's entirely my fault, not hers. You guys, really, there were so many great questions, and we are creating, for those who can support at a coin holder level, at an exchange supporter level, we are going to do extended Q&A in the fall a lot more often. So hopefully you can get a chance to ask your questions live and in person, and on Zoom. But thank you for so many great questions. You're such an engaged audience. We can't believe you guys.
I know. This has been such a gratifying experience for us. We've really done, it's been a lot of work for the whole team, but we're excited to continue to bring you this programming. And if you have suggestions for ideas or speakers, don't be hesitant to email those to us. But in the meantime, we'll be back in September, and we look forward to seeing you then.
Thanks, everybody.